Hi, my name is Lerato. Welcome back to our gentle introduction to GIS tutorial series. This is part 2 in our discussion of attribute data. In this screencast, we will look at using symbology based on attributes. We saw in the last screencast that vector attributes are stored in a table by the GIS application. A GIS application has the ability to symbolize features drawn to the map view based on attributes. There are different types of symbology that can be applied to a vector layer. The most basic type, simple or single symbol, does not use the attributes of features to define their style and color. It just draws everything in the style that you specify. The options for single symbol depend on the layer type. Point layers allow you to select a point symbol that will be drawn at each point position on the map. If your layer has a polyline geometry, you have the option to define the line thickness, style, and color. Single symbol options for polygon layers allow you to specify the outline thickness, style, and color. You can also specify the style and color for filling the polygon. We can use vector attributes to visually group features using graduated symbols. For example, here we have a map of municipal districts. By default, the map is displayed as simple polygons using a single symbol. We can use the population attribute data field in this layer to create a map that color codes municipalities by the number of people living in each. By changing the symbology type to graduated symbol, we can do this. First, we choose the field from the attribute table that we want to use as the basis for our symbology. Then we tell the GIS application how many class groupings we want. The GIS will look at the population data and calculate the numeric range for each group. It assigns a default color to each group, which we can change if needed. While we are here, we can also take a moment to tell the GIS application to label each polygon. To do this, we select the Labels tab and then tick the box that tells the GIS that we want labels. Next, we choose the field from the attribute table that we want to use for labels. We can also choose the font size here. And there is an option to draw a lighter colored buffer around each label to make them more visible. When we click OK, the GIS redraws the map using the gradient symbol, the graduated symbol we have defined. Now it is very easy to see the municipalities that have the highest populations in the Eastern Cape. Sometimes it is useful to have features symbolized in a continuous color gradient rather than grouped into separate classes. To do this, we can use the continuous color symbology. Let's open a vector layer containing contour data and take a look. Once again, we can see that by default, the contours are drawn with a single symbol. By changing the layer properties, we can choose the continuous color symbology option. Like the graduated color option, the first thing we need to do is choose which attribute field we will use. In this case, we will choose the height of contours. Now we define a start color and an end color. And the line thickness to be used for drawing the contour lines. It's good to use two contrasting colors. When we click OK, you can see that the contours have been shaded in a color that is in between red and green. It's now very easy to see which are high-lying areas and which are low-lying, all thanks to continuous color symbology. Finally, we can use a unique value symbology if we want to assign symbology to features based on a particular value they have. We showed you this briefly when we started introducing attribute data. Let's take a closer look. Here you can see a houses layer. If we want to draw houses with red roofs differently to houses with black roofs, unique value symbology will let us do it. Once again, you can see that when we first add the houses layer, they are all drawn using a single symbol. By opening the layer properties, we can change the symbology to unique value. Now we choose the attribute field that will be used. We are using roof color for this example. You will see that the GIS has found each unique roof color attribute and listed them on the left. By clicking on each entry, we can change its symbology. Let's make red roofed houses draw with a red fill and black roofed houses draw with a black fill. When we click OK, we can see the houses drawn according to their roof colors in the map view. That brings us to the end of the screencast. During the screencast, we looked at the different ways a GIS can draw features based on their attribute values. With a single symbol, the GIS draws every feature with the same style and color. Graduated symbols group features into classes based on a value range. Continuous color symbols draw every feature using a range of colors. With unique value symbols, each different attribute value is given its own drawing style. In our next screencast, we will look at how vector data can be digitized in a GIS application. See you then.